Our next talk by Dennis Müller, an HTML CSS schema for whatsits.
That's the old name.
That's the old name, all right.
In the meantime, I learned that whatsit means something different, so I changed it.
I was going to say, that sounded very unusual.
Right. First of all, thank you very much to the organizers for accommodating me in the schedule. Today is sandwiched between my girlfriend's birthday yesterday and a gig with my band near Munich tomorrow. So I'm here today only, which means if any one of you wants to talk to me, make sure that you do that today. Yo. There we go. So, to some extent, the title of the talk is now a bit of a misnomer. Both the talk and the paper are going to be about RusTeX. The idea of RusTeX is that it's a tech engine implemented in Rust that converts text sources to HTML. I say it's a misnomer because in the paper I actually describe all of the CSS and HTML schema that RusTeX uses. In this talk, I'm not going to do that because that would be really boring. Instead, I'm going to spend the talk basically showing you some things and justifying my life choices, I guess. So the core idea behind RusTeX is that unlike most other conversion engines, it tries not to implement any dedicated support for specific LaTeX macros or packages or so on. Instead, it tries to behave as closely to the PDF LaTeX core engine as possible, producing the same kind of boxes as output, and then trying to map those primitive boxes directly to HTML nodes, usually diffs with some CSS annotations. Ideally, that means that given any arbitrary text file which actually compiles without errors in PDF LaTeX, it should also compile with RusTeX. And ideally, it should also, the resulting HTML should look reasonably similar to what you would expect from what the PDF looks like. So in that sense, you can see the whole thing as kind of an experiment. Is that even possible, given the very different box models that TeX use and that HTML CSS use? Spoiler alert, the answer is surprisingly well, of course, with a couple of caveats. So first justification, why do we even need yet another text-to-HTML converter? There are already dozens out there. And to justify that, I have to go into details on our use case. I gave a talk at last year's TUG about the STeX package, so I'm just going to very briefly skim what we're trying to do. The idea of STeX is by the head of our research group and my former PhD advisor, Michael Kohlhase, which I think some of you might know personally. And the idea is that we can represent both the layout of a document, primarily targeted mathematical documents, and the flexiformal semantics of the various statements in that document in the same document format, i.e. in TeX. Then ideally, what that allows for is that we both have a human-oriented document and a machine-oriented representation of the semantics, which we then can have various knowledge management techniques act on for additional services, such as disambiguating symbols, interlinking them, linking them to definitions, giving you exercises, examples for various things, up to type checking, or in some ideal world, even interactive theorem proving at some point. And the way that that works is that instead of using the usual LaTeX macros that you would use to typeset some mathematical formula, instead you import some module that gives you declarations that correspond to the various concepts that you use in there, and then you use semantic macros like this \series, and that way you get the same output, but now the system basically knows, this sum underscore I equals 0 represents a series over some sequence, and you can declare the sequence as a variable or as a constant sequence, and so on and so forth. So you get the same output, but now you have something that is machine actionable. And of course, the whole thing is highly modular. We collect definitions and concepts declarations in modules, which in turn import other modules, which in turn import other modules, and so on and so forth. So basically modules act like LaTeX packages, but for mathematical concepts rather than typesetting macros. And the way that that worked pre-2021 roughly was that in order to get that to work with PDF LaTeX, you needed to use dedicated document classes. You had to set various system parameters of TeX in the first place, which was always a pain if you had anyone who just wanted to start working with that. Then that you needed additional software even to get it to work with PDF LaTeX, just to like be able to resolve all of the like module locations where LaTeX can find them and so on and so forth. And then you get PDF, and that PDF is just human-oriented. And then additionally, if you want to have something machine-oriented, you have to use a LaTeX-ML plugin, which only worked for a very outdated version of LaTeX-ML, so you had to find that and then install the plugin, and then that generates OnDoc, a representation format also developed by Michael Kohlhase that can actually represent the formal semantics of statements, with which a priori you can't do anything. If you want to do something with that, you have to use an additional piece of software called MMT, which then imports that. So the whole tool chain was utterly insane. It was barely usable by anyone except for Michael himself. Indeed, I myself never actually got it to work. So by 2017 already, that was practically unusable. And then after I finished my dissertation, which was in 2019, after a brief stint, I went up to Michael and basically said, hey, I love this idea, this is awesome, this is perfect, but nobody can use it, we can do better. So what we wanted instead is have a single LaTeX package that you can just import anywhere in books, in slides, lecture notes, whatever, just a drop-in usual document package. You should not need any additional software to have it run with PDF LaTeX, because I want to be able to write papers with that. And if you write papers, you have to at some point submit your sources, and then if you need shell escape or additional software, that just doesn't work. And of course, instead of producing separately PDF-oriented for humans and OnDoc-oriented for machines, why don't we use the same representation format for both? And then the idea was, instead of converting to OnDoc directly, we would just convert to HTML and store all of the semantic information that we're interested in there as annotations on the DOM. And if you do that, you don't just have the human-oriented version and the machine-oriented version, but you have both in the same format, which also allows you to then inject additional services via JavaScript into the HTML that actually act on the semantics. And that was STEC 3, and that's what I gave a talk on last year. So what does that mean? That means we need a TeX-to-HTML converter that ideally can deal with arbitrary LaTeX, where by deal I mean it should yield HTML that looks reasonably similar to what you would expect. It needs to be able to preserve the semantic information that we compute basically in the STEC package, and then that should survive the conversion to HTML process. And since our expected corpus of STEC documents is highly heterogeneous, it should be virtually guaranteed that it succeeds for any valid LaTeX file. Even if like the output might look broken, if the conversion succeeds in the sense of that it does not fail, at least we have a document where we can get at the semantic information, even if it looks kind of broken. And also at that point, we had a new research project approved, the VolKI project, whose goal it is to improve college-level education using AI techniques, whereby AI, we usually mean good old-fashioned symbolic AI. And of course, for that, we wanted to use STEC. And if we're now planning to rewrite STEC basically completely, then we better do that now, and then time is of the essence. And it turns out that none of the existing TeX-to-HTML converter were able to do all of the things that we needed it to do. At that point, a couple of weeks ago, I figured let's do some statistics. So I picked my directory on my hard drive where I have all of my LaTeX files. I'm sort of a data messy, so I still have like old homework assignments from college and all of that. Exclude all of the stuff that actually uses STEC, because STEC does unspeakable things, which I can not reasonably expect any converter to deal with. and then see on how many of those documents the converters actually succeed. And it turns out, if I were to like actually write down the statistics here, that would be highly misleading. Misleading because with pandoc, I basically didn't get anything to work at all, which I'm almost sure needs to be my fault. For TeX-to-HTML, it worked reasonably well, so I got 60%. And for LaTeX-ML, the timing was just really bad because the current version of LaTeX-ML does not work with the current version of TeX Live as soon as XPL3 is involved. I know that that is a temporal problem. I know that Bruce Müller is heavily working on fixing that, so yeah, that makes it a bit difficult. But let's compare. Anyway, here's one document that I managed to get to work with PDF LaTeX, RusTeX, TeX-to-HTML, and LaTeX-ML. My undergraduate thesis, actually. So this is the output that you get from TeX-to-HTML. Looks reasonably well, but one thing that you might notice is I have a theorem here, and that theorem has a proof, and that proof has 3 steps, and then I have a list that starts with proof of 1. And then in that list, I have a second list that starts with idempotence and absorption. And what I get out of TeX-to-HTML is just bullet points. That is kind of a problem in this particular setting because like the listing names actually do have important information. If I do the same thing with LaTeX-ML, the first thing that I notice is that it's not usable immediately just because we live in an age of like 8K screens. Right, so you get this weird centered thing which is somewhere after the end of the line and all of that. But both for TeX-to-HTML and LaTeX-ML, before I'm being accused of being unfair, the good thing about both of those systems is that you can easily fix that. You can just add your own CSS and make it look nice. So let's take the LaTeX-ML output, add a max width, and while we're at it, also change the fonts because I don't like the standard fonts. In particular, the ones for math I don't really like, so let's just switch both to Latin Modern, and ta-da. That looks nice. If it works, in particular, my claim would be that LaTeX-ML has probably the best MathML output you could possibly wish for, so that's nice. So with some massaging, which you can do, you get really nice documents, and this is what it looks like with RusTeX, basically the exact same thing as the PDF. In fact, recently my professor complained that whenever I show him screenshots, he can't tell anymore whether it's the PDF or the HTML, which is often the case, but of course you can find scenarios where that entirely breaks. Yes, sorry? Sorry? No, the links? There are links there, but they're highlighted exactly as they would be by PDF LaTeX. These red boxes that you get are inserted by the PDF viewer, actually. So therefore, you don't get them over here. But they are links. You can click on them and jump to the right position. OK, so for relatively reasonably standard LaTeX documents, both TeX-to-HTML and LaTeX-ML work really nice, especially you can add your own CSS, which is an advantage on its own. With RusTeX, you can't do that. So what happens if we like go down a couple of levels? Here's a ridiculous example of what you can do in TeX just by using H boxes with various parameters. So you can do these things on the left just by like adding widths and twos and heights and depths and all of that. RusTeX reasonably tries to do the same thing. In both TeX-to-HTML and LaTeX-ML, you lose a lot of information. What is the cost of that? Well, the cost of that is that this is what the HTML looks like that RusTeX outputs. It basically looks like the kind of HTML that you get if you use like a modern web framework like React or whatever. Here, similar thing, what you can do with like various types of V-boxes. You can like do really weird alignments of those. RusTeX, again, tries to mimic that. LaTeX-ML at least realizes that this is a V-box, so it like puts line breaks between the things. TeX-to-HTML, just plain thing. And a similar thing with like fills and skips and these kinds of things. For some reason, TeX-to-HTML here also does the color wrong, but that's probably just a minor issue. So you might think, why do we care about like H boxes and V boxes? My claim is, to some extent, you should, but that's not a fault of TeX-to-HTML or LaTeX-ML, because both of those systems have very clear use cases. And I think the examples that I just show you kind of demonstrate what the point is. With both TeX-to-HTML as well as with LaTeX-ML, you can generate relatively simple, nicely customizable HTML that mimics what the system thinks you intended to do based on your usage of TeX macros. So they focus on those kinds of macros and packages where there is a clear notion of what the expected HTML output even is. Try to keep the HTML plain and simple so that you can like customize it yourself. And that's all perfectly valid. But the result is that both of those engines can be easily tripped up if they encounter unexpected macros, if they use packages that are squarely outside of like a certain comfort zone, to call it like that. And in order to achieve these, they often tend to neglect in-depth support for low-level TeX primitives, where in-depth support to some extent would entail things like actually putting fixed dimensions in your HTML, which you also don't want to do if you want to have like nice plain HTML, in particular if it's supposed to be responsive. That is very much contrary to common practice. If you think about how most LaTeX users actually use LaTeX, I would claim there's almost no one who does not have like a single TeX file with just collections of macro definitions that they copy and pasted from friends, colleagues, Stack Overflow, by now probably ChatGPT, with a bunch of packages that you just have in there because you have them in there, which you then reuse over and over again. I mean, you guys probably don't because you know how TeX works, but I would claim the average LaTeX user works precisely like that. And that means if you just take an average LaTeX file that works perfectly fine with PDF LaTeX and you feed it into one of those engines, it's quite likely that something is going to happen that makes the thing crash. Right. So, and the idea behind RusTeX, therefore, was if we actually actively try to avoid providing any kind of special support for LaTeX macros and instead try to do everything with the primitives, then we can achieve the goals that we needed to achieve, i.e. it should ideally compile, if it compiles with PDF LaTeX, it should compile with RusTeX. It should look somewhat similar as the PDF is expected, but of course at the cost of document semantics. So basically RusTeX generated HTML is just deeply nested diffs everywhere with CSS. If you're interested in the CSS schema, see the accompanying paper. Now to show you some examples. That should not be too surprising. You've seen lists before, also section headers. So far, this is just basically what you would expect if you like put a document like that into PDF LaTeX. This is the PDF that you get. This is the HTML that you get with RusTeX. For something more interesting, here's a table inside an MD framed environment where the MD framed environment uses vertical and horizontal rules to actually construct a box. RusTeX tries to perfectly mimic that, and that works reasonably fine. The most dire thing that I've noticed so far happening is that occasionally the box is a bit too high. That's the kind of thing that I personally can live with. Yeah, but of course that also means in this case responsiveness with respect to the HTML is probably going to be somewhat out of the window. If you now scale this down to too much, text will just protrude out of the box. But if you don't do that, if you just look at it in a browser, it's basically going to look exactly like the PDF. Listings. I have no idea how listings internally works, and I don't need to. If I do begin listings, it will do some kind of magic. Ultimately, it produces boxes. I just translate those boxes to CSS, and I get the basically exact kind of thing that I get in there. In particularly with these like gray bars, which are probably difficult to see depending on what kind of contrast you have. Yeah. Bibliographies, I don't need to have any kind of process to mimic BibTeX. If you compile it with PDF LaTeX, you get your BBL file. If you then compile it with RusTeX, you get your bibliography, exactly how it should be. One personal highlight of mine, I re-implemented the whole, oh yeah, sorry?
Can you go back one slide?
Sure.
Between the PDF and the RusTeX version, there is a case change in the word visited inside parentheses.
Whoa! True! I have no idea how that happened. That is even weirder.
It means with the source code, it's always lowercase with the last one, which is uppercase, but somehow your algorithm translates it into uppercase by default.
Yeah, that's broken.
My algorithm doesn't do anything with BibTeX in particular. So there must be a tech reason, and probably an associated bug somewhere, probably something like UC characters or lowercase characters or something like that. That might be a bug, but I have no idea. It also might be just a difference between versions, like the PDF I've had lying around since like 2019 now. The RusTeX generated is relatively new. There might be some discrepancy like that. I honestly can't explain how that happened, but good catch. Yeah, thank you. One personal highlight, I was re-implementing this whole CSS schema a couple of months ago, specifically for writing the paper. And one colleague of mine, who we now forced to use STeX, at some point complained, hey, I'm doing this algorithm and it looks horrible. So I figured, okay, let's see what does my new CSS schema do with it, and it popped out exactly like that. So that was a success for me personally. T-color boxes generally also work really nicely. Again, here responsiveness is basically out of the window because, as it turns out, apparently T-color box uses PGF in the background, and PGF is converted to SVG. And of course, you can like scale SVG in theory, but you can't scale it such that it like perfectly adapts to however big like your text is or whatever. Also, one thing, the box at the end of the proof is not where it's supposed to be. Why? Because HTML and CSS don't have a thing like put infinitely growable space here. So there's no current solution that I can think of how to deal with that. If any one of you knows CSS, I don't. Great, talk to me. I'm very open to ideas. I want to make this look as nice as humanly possible. A nice paper that was also published a couple of months ago, Every Author is First Author, where they finally solved the problem of what should the author order be in some paper. Their solution was, let's just print all of the name on top of each other, and described how to do that in both TeX and HTML. I love this paper. I ran it through RusTeX, and it looks exactly as it's supposed to be. So that also a personal highlight of mine. And why we're doing this whole thing, this is what the average STeX document looks like. This is one of Michael's lecture notes. He usually uses the slides that he does in his lectures and intersperses them with like explanatory text. And basically everything you see here is outsourced into individual files so that you can properly reuse them. So you probably have like this introductory text and the slide in one file, then the next paragraph you have in a different file, and all of the definitions and the axioms are also different files and they're included. And of course, if we do this kind of thing and we generate HTML anyway, then we want to not have to recompile all of the included stuff. Instead, we want to compile everything individually and then dynamically insert them into the HTML, which means to some extent our documents need to be responsive. And they are. This is the HTML. Looks exactly how it should be. And now, of course, what you can do with the whole STeX system is you can do things like hover over symbols, and it will show you the definition, and you can do that recursively. And yeah. So conclusion, there's still lots of work to do. Some things look really ugly. It's by now relatively difficult to find those. But if you want to look around, this courses.volki.fau.de link is where you can find our course portal with all of the lecture notes. The other URL is where you can find all of our stuff. And by that, I'm basically finished. Thank you.
Thank you.
Thanks. Yeah, on your nested divs, So the usual advice for people writing HTML is kind of not to do that. I mean, how is your view to like accessibility? We had a workshop on tagging yesterday. I mean, how is a screen reader, if everything's a nested diff with CSS, do you mark up headings? I mean, all the usual document structure things, are they gone internally?
They are largely gone, yes.
Yeah, that's
so
going to be a problem.
accessibility
It's going to be a problem for a screen reader.
Yes. I haven't tried it yet. If there's something we can do about that, I'm very keen on having that work. With respect to MathML, we've now added macros that allow you to annotate it with MathML intent, which is like the accessibility feature of MathML 4. So in that direction, we have something. With respect to generated, the rest of the HTML, I would need to grab someone who actually knows all of the accessibility features and help me with that. For now, probably, sorry, no, but yeah, it's on my plate.
I wanted to ask how is your support for matrix and mass mode and like more complicated two-dimensional formulas with arrows and things like?
That should work relatively fine. I'm largely following the quote-unquote default mode to map tech things to MathML. It might look a bit more ugly because if you do it really on the level of primitives, then you very often escape from MathML to HTML back to MathML. So the trees might look ugly, but things like matrices are not a problem. It's just an M table. Right?
Okay, cool. Thank you.
So I know of all of your efforts with these unpronounceable backends for archive to convert that to something that is browsable.
That is not me.
That is not me, but it's also by Michael Kohlhase.
Not really. It's by the LaTeX people, which is Bruce Müller and Dan Gineff. And Dan Gineff is a PhD student of Michael's still. So there's some association there, but LaTeX is a different piece of software.
Because I was thinking whether RusTeX would finally be the silver bullet to do this.
You can already do this. It's called R5ML. So if you go on archive.org and you just put any paper and you replace the X in the URL in archive by a 5, you get the HTML5 version generated by LaTeX.
Unfortunately not. It's not a running service. They just converted. And sometime in 2021, they converted all previous papers to HTML5, but new papers are unfortunately not converted.
They run it once a month. So they're behind by 1 month, but they're also heavily working on speeding up the whole process. The problem with LaTeX currently is that it's a bit slow, in particular if it depends on XPL3, because then it has to like parse the whole 20,000 lines of XPL3 code.tech or whatever. But they're working on that as well, and they're heavily planning on integrating it as a live service as well, so that you immediately get HTML preview once you submit your sources.
Well, I want to make sure that I understand the last parenthesis on this slide correctly. You have implemented in your RusTeX a complete implementation of the tech macro language and its expansion.
Yes.
Okay.
That I have done. Unfortunately, as I mentioned here, I learned both Rust and Tech while I did that. Yeah. So as a result, to me, this just looks like horrible spaghetti code that should definitely be cleaned up. And that's what I'm trying to do now, like properly modularize it. In particular, I can't handle any kind of ZTech, because ZTech has entirely different character types than like plain tech does. So yeah.
My advice is go away from math, gullet, stomach, and state, and talk about lexical analysis and abstract syntax types, and work on them.
Yeah, I'm doing everything with generics now. Yeah, so that you can just conveniently switch out the mouth by a different mouth, or the stomach by a different stomach, or primitive commands by different primitive commands, and even like the character type, whether you operate on bytes or on actual Unicode characters.
One question: how do you handle marks and inserts? That stuff that goes on top of the page and footnotes and floats and
Currently, I do that by regularly checking if I'm at the top of the document level and then checking whether any of the float registers or any of the inserts are handled. So in lieu of a ship out routine, I'm kind of faking that to generate footnotes and floats. But they will just be inserted at the next convenient place, not using any kind of ship out routine with computing pages and so on and so forth. So that's kind of a workaround currently. But they're there.
Thank you.